Okay, so here is the pretest review. On the first one on this quiz, it says suppose 2 liters of sample of oxygen gas at 0 degrees Celsius and 1 atmosphere pressure contains 0.4 times 10 to the 23rd molecules of oxygen. How many molecules will be contained in 2 liters of ammonia gas at the same temperature and pressure? Okay, some of you guys were asking me, how do we find out what ammonia is? You don't need to know that. You need to know that there is the same amount of volume of gas here that there is here, okay? And it tells you that in this amount of volumes of gas, there's 0.4 times 10 to the 23rd molecules. Same volume, same amount of molecules in here, okay? That's why you get that answer for the first one on this quiz, okay? All right, number 2, the atomic number of krypton is 36. Its periodic table mass is 83.8. What is the mass of 1.2 moles of krypton gas? Well, you set this up. You have 1.20 moles of krypton, and you set it up. Remember, set up, set up, set up. That's what makes or breaks you on these. You set it up so the moles cancel out, and it tells you what the atomic mass is, 83.8. So you put it here, basically multiplying 1.20 times 83.8, and it rounds up to 101 AMUs or grams. Okay. Yeah, this is atomic mass unit, and because of the mole, we know that grams are the accepted unit for that. Okay. All right, next question, number 3. Gas X reacts with gas Y at the same temperature and pressure according to the various laws that govern gas reactions. What would be a volume ratio of X to Y we might get in the lab that would cause us to doubt our data and repeat the experiment? Remember, this is from that video that was made in like 1989 from that chemistry teacher. He was mixing all those gases, and he said that all gases mix together in small whole numbers and small whole integers. Okay, so all these numbers right here, 0.98, 2.01, 2.9, they're all close within acceptable value of whole numbers, right? However, the only one that shoots out that's like, wait a minute, we got to start over, is this 0.30. Okay, right. So if you did that and you got, that was your experimental value, and you're mixing volumes of gas, and it's not a whole number or it's not close to it, then you have to say, I got to rethink this or redo it. Okay. All right, number 4, which quantity is equivalent to 39 grams of the substance sodium fluoride? So now you're just going from quantity to moles. All right, so 39 grams of sodium fluoride times 1 mole, and I got 42 grams by adding all of the atomic masses of this compound. So you're basically going to divide 39 by 42. You get 0.9285 moles, and it just rounds up to 0.93. Remember, I said don't worry too much about the rounding. You should be able to pick it out in a multiple choice. This is an example of that. All right, number 5, Rutherford's gold foil experiment led to the conclusion that each atom in the foil had a dense and positive charged nucleus because some alpha particles directed at the foil were deflected by the nuclei in gold atoms. Because an alpha particle, remember, is a helium particle, and it's charged. There's no electrons to it, so it's just got a mass of 4, 2 protons. And when those hit the nuclei in the gold, since the nucleus is positively charged, it repelled it, and that's how you discovered the proton. Okay, so there was something in there that was positive that was deflecting those others. Like charges repel. So if you try to get the same side charge of a magnet together, it's going to repel. Okay. All right, so number 6, the atomic number of helium is 2. Its atomic mass is 4. The atomic number of oxygen is 8. Its mass is 16. Wow, that's great information, okay? However, it's not relevant to what it's asking you, okay? It says compared with a mole of helium, a mole of oxygen contains what? A mole of any gas is going to be what? The same. An equal number of atoms. Okay? All we've got to do is put a number to it, right? 6.02 times 10 to the 23rd. All right. Number 7. Which best contracts nuclear fission and nuclear fusion? I drew the picture here. This is a nucleus hitting a uranium. When it does that, it makes a massive reaction, violent reaction, and you get 2 smaller radioactive isotopes after that, strontium and radium. And then you have these other the other neutrons that are going out, and they're going to perpetuate this even further, so it's going to cause a chain reaction. So what's happening, fission, is the breaking apart of, splitting of large nuclei. Uranium is very large. Fusion is joining of small nuclei. These are smaller. Okay, these were joined because of this reaction. Okay, or they form those 2 smaller ones. Number 8. What is the change? What is the change in atomic number when an atom emits a beta particle? Well, if you emit a beta particle, you're going to increase it by 1. Remember, a beta particle is that electron. You add, when you subtract it, you subtract the negative number, it makes it a positive mathematically, so it adds a proton or a +1 charge. Okay. Okay, on the back, here it says, what would be the volume of 0.5 moles of methane gas at center temperature and pressure? This is one of those volume questions where you had to use that conversion factor. And the way you set it up, 0.5 moles of methane. You could have just wrote methane here. You didn't have to write CH4 times 22.4 liters is 11.2 liters. Last question, and make sure you know how to do this. Element Q has 2 naturally occurring isotopes, 304 and 308. If the abundance of 304 is 50, what would be the mass of Q on the periodic table? This is where you use that equation of abundance of 1 times atomic mass of 1 plus abundance of 2 times atomic mass of 2. Basically, it's here. This should be an 8. 308 times 0.5. Basically, you do that math, and it comes out to 306. Also, make sure you know the difference between the Dalton, Rutherford, and what was the other guy? Thomson models. Okay, know the Thomson, all the difference between these models. Okay. So what'd you get? 9.26 times what? 10 to the 23rd? That's about right.